Okay, question 33, you actually do not need to do any calculation, you can just deduce it. Now, regarding brightness, brightness is light energy. Light energy give you, light energy is related to power. So when you're examining brightness, don't just examine current only or voltage only. You are examining the power. So power is equals to P equals to IV. Now the thing is, when you have a lamp in a circuit, most of the time you do not know what is the voltage flowing through it, right? If I just tell you this, I tell you that this is 10 volt, can you tell me immediately what is the potential difference of this lamp? No, right? So it is quite difficult. Now, one thing is certain, that for lamp, the resistance is fixed. So your P equals to IV formula, if you want to apply it to any lamp, is quite difficult because you have two unknowns. You do not know the current, you do not know the voltage. So it is best you use the formula P equals to I square R, because then R is fixed. Only I you require to check on it. So let's apply P equals to I square R to determine the brightness. Now the tricky thing about this is that it is like a parallel and series circuit. It is parallel connected here. It is series connection when you're talking about L2 versus this whole chart. So let us analyze L1 first. Now the thing about L1 is that as you move J towards X, what happens is that this resistance is going to increase. And when this resistance increase, what happens to the current flowing into this wire? If this resistance is going higher and higher, then the current going to this branch will become more and more, because it is harder to flow through here already. Okay, it's becoming increasingly difficult to flow through here. So meaning that more current will come here when the resistance here is increased. So when J move to X, more current will flow to L1, and when more current flow to L1, basically your power will increase. So more light will be emitted in L1. So you know that L1 will be brighter. So this one is correct, this one is correct, this is wrong, this is wrong. Okay, now the second thing. Now as this resistance increase, the total resistance here, this resistance is going to be fixed, right? No change, right? Because the resistance here depends on the heating element in it. Okay, so if this resistance increase, this is fixed. So overall, when J move to X, this whole combination, the resistance here is going to increase. So when you have a fixed resistance here, and the whole resistance of this group is increasing, meaning that this guy is going to receive more or less current. Do you know? You do not know, right? In fact, here and here, if I combine this, that means if I combine this thing into a resistance, okay, I combine this lamp and this resistance, I go and find the effective one. I know that when J move to X, this resistance is going to increase. Okay, fine, I don't have one. So I know that this combined resistance is going to increase. Do I know what will happen to the current here? Quite difficult to tell. So that's why down here you can't really use I square R. It's quite difficult. So what do you use? What is the other one? P equals to? For me, I don't remember, to tell you honestly. I will use P equals to IV. Okay, then I know that V equals to IR. So then if I combine these two formula together, I will get P equals to V, what will I get? V square over R, right? I will get V square over R, correct? So I will get V square over R. Did I make any mistake? I'm very afraid if I make any mistake. Did I? Nope. Nope, I didn't make any. So V square over R. So if you have V square over R, if this resistance is increasing, that means there will be more, because this is in series, right? So if this resistance increase, that means my voltage here will increase. If my voltage here increase, that means my voltage here will decrease. So if my voltage here decrease, then P equals to V squared over R. My power is going to decrease, so it will be dimmer. So answer is your A. Okay? That's how you do it. Okay? Of course, there's other approaches. Another approach is that you think about the total resistance here. So if this resistance increase, the total resistance of this entire circuit is going to increase. Now when the total resistance of a circuit increase, and if you keep the battery source constant, the overall current is going to decrease, right? Because now your resistance is increased. So if the total current decreases, just by P equals to I squared R, you can also deduce that the power from this light is going to decrease because I is going to decrease. Okay, so there are quite a number of ways to do it. Okay, question 34. Question 34, you have be very careful. This is your power, it's not your resistance. So what you need to do is use your P equals to VI formula. You know that these two are connected in parallel to the battery, so you know it's going to be 24 volt. So with this, you can find out what is your current. So your fuse is here. So add together, you have your total current here. You know that your fuse must be bigger than this. Option C. 35 is very interesting. Which of these 5 events would cause the fuse to blow? So what you need to do is quite easy. You need to have the awareness that the person is like your earth wire. A person, you can assume it to have 0 volt in terms of potential difference. So if 0 volt touch your earth wire, which is in 0 volt, they are of the same potential difference, right? It won't have any effect on the current, on the circuit. So 0 volt touch 0 volt, nothing will happen. The fuse will be okay. A person touch a neutral wire is also in 0 volt. So 0 volt touch 0 volt, nothing will happen. Now a person in 0 volt touch the live wire is high potential difference, 240. So there will be a large current flowing through, the fuse will blow. So the fuse will blow. Live wire touch neutral wire, so 240 volt touch 0 volt, it will blow. Live wire touch earth wire, 240 touch 0 volt, it will blow. So your answer, C. Okay? 36, just be very careful. Live wire must always connect to your switch. Your metal casing will always connect to your earth wire, and with that you can actually conclude your answer is B. Okay? 37 is very interesting. 37, you see that this compass is not affected by this pole and this pole, and it is actually aligned to the earth magnetic field. So what this thing is telling you is that there must be a repulsion occurring such that, oops, I draw not so nice, such that the center part is being shielded. Okay, so this is the magnetic field. Notice that I haven't drawn the arrow yet because I do not know which direction. Okay, I do not know. I only know this is shield. So I know that A and B must be of the light pole. So light pole, light pole, light pole, light pole, light pole. I know that B and D must be our answer. Then how do I know is it north-north or south-south? I look at this compass. So this compass is going in. So meaning that my magnetic field is actually going in. And going in means that this is south. Okay, so I know that it's going to be going in. Yeah, it must be south. South. So this is wrong. Oops, made a mistake. This will be D. Okay, going in will be south. Okay, question 38. Which statement is true? So this is a motor, so use your left hand rule. So it is going clockwise. If I look at the wire here, this one, where my pen is pointing. So clockwise, so meaning that the force is pointing up. Magnetic field is by this finger, north-south, so I have to turn my hand like that. Okay, so I know that the current must be going down. So going down, meaning that my X must be a negative terminal. So I look at this, it's factually wrong. Y is not negative, Y is actually positive. X is the negative terminal. Okay, no moment acting on the coil when the plane is perpendicular. So they are using a split ring commutator. So when this coil is in the vertical position, the connection here will be at the split junction here. So there will be no contact. No contact means no current. No current means no magnetic field interaction. That means no force. No force means no moment. So yes, 2 is correct. The coil will rotate at a smaller speed when a lamp is connected in series. So when you put a lamp in series, basically what you did is that you have actually increased the effective resistance of the entire circuit, and therefore reduce the amount of current in the whole circuit, and therefore reduce the rotational force, and therefore 3 is right. So you got your answer, C. Okay, question 39. 39. Now, what happened is that by Lenz's law, if this thing is going to fall down, it's going to experience an increase in magnetic field strength. So what will happen is that there will be a current formed here to oppose this change. So to oppose this change, you would want to have a south pole here and a north pole on top, because like poles will repel. So to have that, use your right hand rule. Okay, you want north to be upright, so it will go this way. So it will go this way. This is your current in your ring. Okay, so with that, induced current flowing anti-clockwise, that is what is happening. It is anti-clockwise. So number 1 is correct. The reading on the balance is constant before the ring rests on it. It is not going to be constant because of this force of repulsion is going to act onto the downward acting force on this magnet, and then eventually on the weighing machine. So there will be an additional downward force. The reading will not be the same. Temperature of the iron ring will increase. Okay, because this current is just flowing and is doing nothing. Okay, so the energy in the current will be dissipated as heat, and so temperature of the iron ring will increase. Okay, that's 39. Okay, for 40, you need to read the OCR reading and be very careful with the unit here. So if you read correctly, the voltage is going to be 40 millivolt. The period is from peak to peak. So you get 20 milliseconds. When you convert it to frequency, be very careful about this millisecond. Okay, you need to convert it into seconds first before you convert it into frequency. So once you have that, okay, you can find out that your frequency is 50, so it's either this or this. Then from the voltage, you know the term ratio, 1002 to 120. So do your conversion here. You find that the primary voltage is 400, and that's it. Okay, good luck.